So example 3 is the same kind of idea as examples 1 and 2, other than this one is now dealing with a mean rather than a proportion. So the process is still the same. We still start with HA. The difference now is we want to prove that packages of post-grape nuts average less than 24 ounces. So this is an average or a mean less than 24. So notice the big difference here is the parameter we're estimating is no longer P, it is now mu. H naught, which contradicts that, is mu greater than or equal to 24. That is our first step. The second step is to find our test statistic. So the sample mean has already been given to us in this case. The sample mean is x bar equals 23.94. So we need to find z. Obviously our z formula is going to be different since we're dealing with the mean. This formula should look familiar to you. X bar minus mu over sigma over square root of n. So we plug in what we know. We know x bar is 23.94. We're comparing mu to 24, so we're assuming that mu equals 24. Sigma is given to us at 0.13, and we're sampling 100 boxes in this case. So we crank out the math here. That'll give us our test statistic. If you work this out, you'll get negative 4.6. So that is step 2. Step 3 is to find our p-value. Once again, p-value is the same as it was before. This is a z. Negative 4.6 is way down here somewhere. And we want the area in the tail because we're testing less than. So this area, that is our p-value. Once again, in this case, the negative 4.6 is off the table. So we basically have 0 area down there, or our p-value is basically 0. Our p-value is 0, alpha is 0.05, so that means our p-value is less than alpha, which means we can reject H naught in this case. So we reject H naught because the p-value is less than alpha. Since we can reject H naught, we can conclude that HA is true, or conclude that packages of post-grape nuts has a mean less than 24 ounces. And we used alpha equals 0.05 in this case once again, so we're 95% confident in that conclusion.